What's up everybody, this is Teacher Ivan from NextGen Academy. Our goal in this channel is to help you achieve your highest potential and to help you understand subjects in the easiest and the most efficient way. If you'd like to get more tips and tricks on how to achieve A star in your IGCSE, don't forget to like, comment, share and subscribe to this channel. Lastly, if you need any help in your studies, you can always head on to our website, link in the below, or our Instagram. Drop us a DM and we'll be able to help you. Enjoy this video and I wish you all the best. What is up, NextGen? This is Teacher Ivan here, and yeah, look at my arms. It's a little weird because I got into a very bad motorbike accident a few days ago. Got into the hospital because a little boy, he's not very little, but he was quite big size. He crossed the road without seeing, and I was on my scooter, so I ride a Vespa to my school, and he ran into me, and that's how I got into all these injuries. So if you're wondering like why my arm is like really weird, that is the reason. Okay, so I think most of you are also preparing for your IGCSE paper. So let me help you with this paper. Today we'll be doing the February-March 2022 paper, set 1-2. Okay, let me join in with my iPad first. Okay. I hope everyone is feeling good and all ready to sit for your IG paper. A lot of people have been messaging me on Instagram, people all over, students all over the world, and asking me, hey teacher, when are you gonna upload this paper? So here I am. Okay, so I'm gonna help you all. Okay, so this is the ADDMATHS paper 1, February-March 2022, variant 1-2. I would say this is a pretty hard paper. Not gonna lie, when I did it that time, I was like, wow, as compared to the previous one, I think some of the questions can be a little bit tricky. So let's get straight into it. So, okay, just a gentle reminder, use blue or dark blue pen. I've heard students who actually did their math paper with pencil. So please do not do that. All right. The only thing that you can do pencil for is your diagram or graphs. Okay. Make sure you write your name. Don't use any erasable pen or correction fluid. Do not write any barcodes. And then use a calculator where appropriate. Make sure you show all your working and make sure it is correct to 3 SF or 1 DP for angles. Okay. This is an 80 marks paper and you only have 2 hours. So make sure you keep track of your time. All right, so let's get it. Okay, so here's all the formulas which I won't go through. And let's go to question 1. Okay, I hope all of you are ready. Find the values of k such that the line y equals to 9kx plus 1 does not meet the curve of y equals to kx squared plus 3x, 2k plus 1 plus 4. So how do we do this? When they say does not meet the curve, the main equation that you got to use is b squared minus 4ac less than 0. Okay, because that's the theory of, or the equation that represent does not meet. Okay, so let's write down the equations first. Y equals to 9kx plus 1. Then the other y equals to kx squared plus 3x, 2k plus 1 plus 4. Okay, I'm going to write this equation 1, this equation 2. We want to first step for this kind of question, whenever you see a curve and a line, make sure you sub into each other first and arrange it to ax squared plus bx plus c. Okay, so kx squared plus 3x, 2k plus 1 plus 4 equals to 9kx plus 1. Okay, so let's rearrange all to one side. I will shift all of it to the left-hand side. So kx squared plus 3x, 2k plus 1 plus 4 minus kx minus 1 equals to 0. Okay, so let's gather all the same family together. So we only got one kx squared, x and x. Then the one that's not highlighted don't have any x. Okay, so let's see. So it will be, oops. kx squared plus 6k plus 3 for this term. I like to put the x behind. Then I gather this 9k together, 9kx plus 4 minus 1, and you get plus 3 equals to 0. Okay? Then, okay, let's gather the k to get the x together. So kx squared plus 6k minus 9k, we get minus 3k. So let's write it as 3 minus 3kx plus 3 equals to 0. Okay, so you all see here, once I have the equation ax squared plus bx plus c equals to 0, then the part 2 of this, okay, the part 2 of this is we put it into ax squared plus bx plus c. Okay, I just write out what's a, b, and c first. A equals to k, b equals to 3 minus 3k, c equals to 3. Okay, so we sub in into b squared minus 4ac less than 0. So there are 3 types of equation, either equals 0, more than 0, or less than 0. When they say does not meet the curve, then we use the equation less than 0. Okay, so this is does not meet the curve. All right. Okay, so let's get this. 3 minus 3k squared minus 4k times 3 less than 0. Okay, we open up the bracket and we get 9 minus 18k plus 9k squared minus 12k less than 0, where you will get 9k squared minus 30k plus 9 less than 0. Okay, so you see it's a quadratic equation. So we want to also arrange it in the form ak squared plus bk plus c. I can divide the whole equation by 3, which will give me k squared minus 9k plus 3 less than 0. Okay, let's factorize it. You will get 3k minus 1, k minus 3. You can either use your calculator or you can use the butterfly method. Once you get here, find the roots. Okay, write the roots first without just ignore the less than 0 first. Okay, so we find the roots already. Then how do we find the values, okay, that satisfy this equation? We draw this. Okay, we draw this. Put the roots here, the small one on the left-hand side, the bigger one on the right-hand side. And then since it's less than 0, then the region is at the bottom here. Okay, so it is in between 1/3 and 3. Okay, so this is how you get your 5 marks for this question. All right, cool. Let's go, next one. Okay, question number 2. Okay, when they say do not use a calculator in this question, do you use a calculator? Yes, you do. Okay, the only thing that they want you is to show your working. All right, you still use a calculator. If you can't count, your calculator is your best friend. So solve the equation 3 minus 5 sub 3 x squared 2 sub 3 plus 5x minus 1 equals to 0. Okay, so when they say the word solve, right, it means I want to find what is x. Okay, give your solution in the form a plus b sub 3, where a and b are rational numbers. 6 marks question. Okay, so let's look at this first. When we look at the equation, right, this is a quadratic equation, right? You see, ax squared plus bx plus c equals to 0. Okay, so we can't use the bracket method, right? When we factorize the, I like to call it butterfly method. In fact, I tell all my students it's the butterfly method. Yeah, we can't use that because, yeah, just look at the values. We can't factorize using that. So what can we do is we got to use quadratic formula for this question. So use quadratic formula. Right? A will be 3 minus 5 sub 3. I just write it down first. 2 sub 3 plus 5 will be for your B, and C will be equals to -1. Okay? So let's put into the quadratic formula, which is your negative B plus minus square root B squared minus 4A C. Okay, then over 2A. Over 2A. Okay, so let's slowly open up all the brackets. So we get negative 2 sub 3 minus 5 plus minus, okay, let's open up this bracket here inside the square root, which will get 12 plus 20 sub 3 plus 25 plus 12 minus 20 sub 3 over 6 minus 10 sub 3. Okay, we got 20 sub 3 and minus 20 sub 3, so you will minus it off. And let's simplify it further. And okay, if you go and calculate inside the square root, you will get 49. And let's see, the bottom, can we do anything? Not really. Okay, so now that we are here, let's continue to simplify it. Minus 2 sub 3 minus 5 plus minus 7 over, oops, over 6 minus 10 sub 3. Okay, I think we can separate it right now because you see there's one equation that will give you a plus, one will give you a minus. So let's do the plus one first. Minus 2 sub 3 minus 5 plus 7 over 6 minus 10 sub 3. I'll use another color for the minus one. So let's just put here minus 2 sub 3 minus 5 minus 7 over 6 minus 10 sub 3. Okay, let's do one at a time. So they say that they want it in this form, right? A plus B sub 3. So as you can see here, at the bottom here right now, there is a cert at the bottom. So we need to do the process or the operations of rationalizing the denominator. Okay, so let's simplify further the top first. So 2 minus 2 sub 3 over 6 minus 10 sub 3. And okay, so we got to multiply by the conjugate cert. Okay, you know what's conjugate cert? Oh no, okay, conjugate cert, we just need to change the symbol from multiply by the opposite symbol. So you see like 6 minus 10 sub 3, you just need to multiply by 6 plus 10 sub 3 for top and bottom. Okay, then we will use, let's cross multiply. We will get 12 minus 12 sub 3 plus 20 sub 3 minus 20 times 3. Okay, at the bottom, we will use the formula A plus B times A minus B equals to A squared minus B squared. Okay, this is how we actually rationalize the denominator. So we will get 6 squared minus 10 sub 3 squared. Okay, which will give you minus 48 plus 8 sub 3 over 36 minus 100 times 3. Okay, let's factorize the top, or let's, because we want to simplify it further, 6 plus sub 3 over, okay, very long on this equation. Okay, you definitely don't need to write every single step, but I'm just showing you all the detailed steps. Okay, then over here, what do we have? We can simplify this, become 33. And we'll get 6 over 33 plus 3 over 33. And we can finally simplify it further to 2 over 11 plus 1 over 33 sub 3, because they want in the form A plus B sub 3, right? Okay, I think if you write it as sub 3 over 33 also shouldn't be an issue. Okay, let's do the negative part. So I think the negative one will be pretty similar also, the steps. Okay, minus 2 sub 3 minus 12. Okay, 6 minus 10 sub 3. Okay, we repeat the same step as well. So we rationalize the denominator. It will be the same value over 6 plus 10 sub 3. All right, let's see. Cross multiply the top and the bottom. We'll get negative 72, negative 12 sub 3, negative 120 sub 3 minus 20 times 3 over 6 square minus 10 sub 3 square. Okay, and then minus 132 sub 3 over 36 minus 100 times 3. All right. Okay, let's simplify it. Factorize the top. 1 minus 3. At the bottom, we'll get minus 264. And we can simplify it. This will be 2. Finally, we'll get 1 over 2 minus 1 over 2 sub 3. Okay, so these are the two final answers. By the way, just to take note, I don't have the official mark scheme, so this is my own answers. The official mark scheme have not been released yet, so yeah, make sure you all check the official mark scheme for the proper marks because it's not released by Cambridge yet. All right, so this is the step for question 2. Okay, for question 2. Okay, let's go. Next one. Pretty long paper, so we will just speed up a little bit. Question 3. The curve with equation y equals to a sine bx plus c, where a, b, and c are constants, passes through the point 4 pi 11 and negative 4 pi 5. It is given that a sine bx plus c has period 16 pi. Okay, find the exact values of A, B, and C. Okay, what I mean, this question is pretty tricky. All right, so let's look at what is the first thing that we can find. They ask us to find A, B, and C, right? And you all should know A will affect the amplitude, B the period, and C is the vertical translation. Okay, that means whether it shifts up or down. All right, so the first thing that I can immediately find is actually this information here. The period 16 pi. Okay, they say that we can, this sine graph has a period of 16 pi. So let's write down this equation first. A sine bx plus c. Okay, a sine bx plus c. The first one, period. Okay, for a sine graph, the equation is 2 pi over b. So this is an equation that you have to memorize, especially in your textbook. For sine and cos, to find the value of b, which is the sine bx or cos bx, period is equal to 2 pi over b. This is for sine and cos. All right, so they say period is equal to 16 pi. So I just put here 16 pi, 2 pi over b. B will be equals to 1 over 8. So this is my value of b, 1 over 8. Okay, number 2, now that we know b is 1 over 8, they gave us 2 points here, right? 4 pi 11 and negative 4 pi over 3, 5. So what I can do, I got 2 unknowns and I got two values that is given to me also lah, my x and y. Then I'll be left with a and c, right? So 2 unknowns, I need 2 equations, therefore I can do a simultaneous equation. That is always the logic of how we actually find unknowns. Okay, next time when you all go to A levels, 3 unknowns, then that means I need 3 equations. 4 unknowns means 4 equations. That's how we normally solve for unknowns. Okay, then we can just do simultaneous equation. Okay, so let's see. So we already know that y is equals to a sine 1 over 8x plus c. And then given to us these 2 points, 4 pi 11 and negative 4 pi over 3, 5. Okay, so let's construct 2 equations from here. We sub the x and y into the y equals to a sine 1 over 8x plus c, which will give me 11 equals to a sine 1 over 8, 4 pi plus c. Okay, just type into the calculator. Okay, don't waste your time calculating it when doing exam, because you will be chasing for time. Okay, sine pi over 2 will be equals to 1. So we will get 11 equals to a plus c. Okay, so this we can consider as the first equation. We do the same thing for the next point here, which will be 5 equals to a sine 1 over 8 negative 4 pi over 3 plus c. Okay, which will get 5 equals to a sine negative pi over 6 plus c, which will eventually get 5 equals to negative a over 2 plus c. Okay, so you see I got equation 1, equation 2. Now, we want to solve for a and c, right? 2 equations, 2 unknowns. Okay, or 2 unknowns, then we have 2 equations. Therefore, okay, let's go to step 3. Simultaneous equation. For simultaneous equation, you can either use substitution or elimination. Okay, my advice for all of you is that if you can do elimination, it will be way faster. Okay, but certain equations you can't do elimination. All right, so in this case, we can eliminate the c because both values are the same. So let me just use equation 1 minus equation 2. So I write it in this form: 11 equals to a plus c, 5 equals to negative a over 2 plus c. Then we minus it. Okay, we minus both of it. Reason being, this one will minus off. So 11 minus 5, you get 6a minus minus a over 2. So you'll be plus a over 2, which will give you 3 over 2a. Then 12 equals to 3a. A will be 4. Okay, a will be 4. And then now I have a equals to 4. Okay, I can sub into equation 1 or equation 2. So let me just sub a equals 4 into equation 1. Okay, so 11 equals to 4 plus c, which will eventually give me c equals to 7. Okay, so we have our a, b, and c. A equals to 4, b equals to 1 over 8, c equals to 7. Okay, find b first because of the information that's given to you. All right, let's go to the next one. Using your answer to part A, find the coordinates of the minimum point on the curve for 0 to 16 pi. Okay, I want you all to take note also. The period for this question is 16 pi. So period is one whole cycle of the sine graph. So we should see one whole complete sine when they ask us to find here 0 to 16 pi also, right? Okay, so they want us to find the minimum point on the curve. I will use the sketching of graph method. Probably you can do dy over dx equals to 0, but I'll only show you all how to sketch graph based. This is the method that I'll be using. So let's sketch the graph. Okay, so for me to sketch a graph of, what do we want to draw? Y, okay, we want y equals to 4 sine 1 over 8x plus 7, right? Y equals to 4 sine 1 over 8x plus 7. Okay, so yeah, I've taught all my students. In fact, there are 8 graphs that you all need to know in your IGCSE ADDMATHS. So sine graph is one of it. Make sure you know how to draw it if you all don't know. join my online masterclass. All right, y'all can. There are students from all over the world, from Indonesia, from Germany, mostly from Malaysia. Yeah, I teach online classes. So if you need help with ADDMATHS, come and find me. Okay, just head on to nextgenacademy.co. That was the advertisement break. All right. Okay, so we always start with the original sine graph first, yeah? Okay, so we know that the original sine graph is 0, 90 degrees, 180 degrees, 270, then 360, right? Okay, then you will get like a S shape like that. Okay, I won't draw the original one. We already know how it is right now. So now let's jump straight to this part here first. Okay, this first part here first. 4 sine bracket 1 over 8x. So we don't do all of it immediately. We do one step at a time. Okay, we know that the period is 16 pi. Period is 16 pi. So my intervals right now, right, what I can do, the first thing that I want to do is I split all my intervals first. Originally, this was 0 degrees, 90, 180, 270, 360. Now I want to split it from to this part here will be 16 pi. Okay, so I got 4 parts to split. The easy way to do it is you just divide it by 4 because all will be the same intervals. Okay, so here I can put 4 pi, 8 pi, 12 pi, then 16 pi. Okay, so this is the logic of it. Then, so this, my graph of the sine graph will be like this right now. Okay, will be like this. And what else do we know? We know the 4, right? So 4 means your amplitude will now become 4 and negative 4. Okay, 4 and negative 4. So let's put here 4 and negative 4. So what I would sketch first is the original, okay, not the original sine graph, the 4 sine 1 over 8x first. Okay, we do one step at a time. So let's sketch this. Okay, so this graph here is y equals to 4 sine 1 over 8x. Then, now only the second part, what I'll be doing is this plus 7. Okay, plus 7 is a vertical translation of your entire graph shifting up by 7 steps. That means all your points will be shifted up by 7 steps. So, what do? There are 3 main points that you need to look at. 4, 0, and negative 4. Basically, your lowest point, your midpoint, and your highest point. Okay, a lot of students always forget this middle point. So shift up all these 3. So 4 plus 7, you will get 11. Then 0 plus 7, you will get 7. Okay, let me just put it here. Let's say 7 is here. Okay, we just roughly Negative 4 plus 7, we'll get 3. Okay, so what I will do, I'll always draw the middle point first. Okay, draw it in dotted line. So imagine your x-axis now shifted to here already. Okay, roughly sketch only because we don't need to draw until very accurate. So now this point here will be here. 4 pi will be 11. 8 pi will be back at 7. Then the 12 pi will be here at 3 because it was your lowest point. And then here, 6 pi. So if I were to sketch the final graph, be something like this. Okay, so this will be y equals to 4 sine 1 over 8x plus 7. Okay? Can Okay, so now that I have this graph, right, what are they asking us to find? The coordinates of the minimum point. Minimum point is here, right? Coordinates means your x and y. So my x here is 12 pi. My y will be 4. 3. Okay, 3, this point. So that will be my final answer. Minimum point will be equals to 12 pi 3. Okay, You probably can use dy over dx equals to 0 also, because that is the equation that represents the minimum point. Go ahead and try it by yourself, but over here, I'll be using the graph to explain and to solve this question. Okay, let's go on. Next one. Question 4. Show that 1 over 2x minus 1 plus 4 over 2x minus 1 square can be written as 2x plus 3 over 2x minus 1 square. Okay, 1 mark question. This is a pretty simple one. So for me, I want to make it to the same denominator. So here I times 2x minus 1 over 2x minus 1. Okay, which would eventually give me 2x minus 1 plus 4 over 2x minus 1 squared. Okay, and I will get 2x plus 3 over 2x minus 1 squared. 1 mark. Okay. Okay, question B. Find, integrate from 2 to 5, 2x plus 3 over 2x minus 1 dx, giving your answer in the form a plus ln b, where a and b are constants. Okay, 5 mark question. Okay, so what I want you all observe here, you all see, right? Normally, when it's a, b like that, right? Then you have to look at the equation. Okay, this one, if you all look over here, 2x plus 3 over 2x minus 1 square, we can't really integrate in this form, okay, at your level right now, at IG level, because you see, it's like a quotient rule kind of form, right? Okay, so what we got to do, we just change it back to the original form. As you can see here, they say can be written as, right? So this one, 2x plus 3 over 2x minus 1 square, same equation. We write it back as the question again. Okay, so I write integrate from 2 to 5, 1 over 2x minus 1 plus 4 over 2x minus 1 square dx. Okay, then let's rock and roll to integrate. Okay, wait, let's simplify it first. So integrate from 2 to 5, 1 over 2x minus 1. Okay, I like to write it as this form first, to the power of negative 2 dx. Okay, then let's integrate here. Here you'll get 1 over 2 ln 2x minus 1. Okay, go back to your ln root, how you integrate ln. We won't have time to explain it here. And here we will get 4 2x minus 1 to the power of negative 1 over 2 negative 1. Okay, then from 2 to 5. Okay, from 2 to 5. Let's sub in the 5 and the 2 and do definite integral here. Half ln 9 minus 2 over 9. This is when I sub in my 5 minus 1 over 2 ln 3 minus 2 over 3. Okay, which will give me 1 over 2 ln 3 square minus 1 over 2. Okay, wait, let me see. Okay, I don't skip the step first. Let's open up the bracket first. So 1 over 2 ln 9 minus 2 over 9 minus 1 over 2 ln 3 minus 2 over 3. Okay, what I want you all to observe here, you see, there are two terms that has ln, right? And you look at the final form that they want you to present in, a plus ln b. So for me, if I go back to my all my rules or laws of logarithms, right, I need to make both the ln to be the same first. Then only I can join with both. Actually, it's not a rule. Okay, anyway, forget that statement. Ln 9 and ln 3, basically for me to join both of it to one ln, I need to change both my arguments to be the same, meaning the numbers inside to be the same. Okay, so 9 can actually be written as 3 square also. Ln 3 square. Okay, I just put the ln together. Then minus 2 over 9 minus 2 over 3, we will get 4 over 9. Is it? is plus. Okay, plus 4 over 9. All right. Use the power rule here. I bring the 2 in front, and I'll get just ln 3. Hold on a minute. There's something wrong here. There's a minus 1 over 2 ln 3. Okay, so the previous equation now, 1 over 2 ln 3 square minus 1 over 2 ln 3 plus 4 over 9. Ln 3 minus half ln 3 because I use the power rule. Okay. Shift it in front. Ln 3 minus half ln 3 will just give you half ln 3. They want to write in A plus ln B, right? So I just put the 4 over 9 in front plus half ln 3. Okay, plus half ln 3. Bam, bam. Okay, let's go. Next one. Question 5. Okay, variables x and y such that y equals to ln bracket 2x squared minus 3 over 3x. Find dy over dx. So we will use quotient rule for this because it's a u over v. It's a function divided by a function. I prefer students to always write in terms of uv first so that you can check it whether you make a mistake or not. So u v3x, u prime will be 4x over 2x squared minus 3. V prime will be equals to 3. And then we put into the formula, which is dy over dx will give you v u prime minus u v prime over v squared. Okay, over v squared. And then, okay, I think if you do it until here already, you more or less would get actually full marks already. So I just want to simplify it further. But if you all are not confident, you all look at the marks here because it's just 3 marks only. Most of the time, if you do until here, or probably the next step, you'll get the full marks already. Okay, so if you're not confident to simplify this kind of question, don't simplify it. Okay, don't do extra steps. Okay, but I'll just show you how to simplify it. Here you get 2x squared minus 3 minus, wait, is this minus? This will be plus 3 ln. Hold on, there's a value that is wrong. Is it plus or minus? vu prime minus uv prime. Hold on. Did I write something wrong? Okay. This is my equation. vu prime minus uv prime. Okay, let's follow through first because I actually did this entire paper midnight and I didn't check through. Oops, my bad. Okay, yeah, so the thing is, yes, don't go and do anything extra if y'all are not sure. Okay, if y'all are not sure. Okay, so if I want to simplify it further, I will get 12x squared plus 3, okay, 2x squared minus 3. That's 3 times 2x squared minus 3 ln 2x squared minus 3 over 2x squared minus 3 9x squared. Okay, this one, if you all do not simplify it, don't do it. Okay, it's actually one of the examples in your textbook on how they simplify it, and this normally occurs when you have a quotient rule. Okay, Don't do it if you all are not sure because it's just a 3-mark question. Okay, then they say, hence, find the approximate change in y when x increases from 2 to 2 plus h. So when they say approximate change, we straight away use this equation. Write this first, delta y over delta x equals to dy over dx. I don't want you all to memorize what delta y equals to dy over dx times delta x, because sometimes they might rotate. They might say, find the approximate change in x. Okay, that's one way that they can test you all on also. So delta x, what they give us, 2 plus h minus h, which will give us minus 2. Okay, my bad. H. So delta x is equal to h. So we want to sub in. Okay, we want to sub in x equals to 2 into dy over dx. Okay, you sub it in. Okay, I think I won't write this, but you just sub in into the value. Okay, into this equation, your dy over dx, you should get 0.1325. Okay, 0.1325. And we sub into this equation, delta y equals to dy over dx times delta x. Okay, which will eventually give us 0.1325 times h, or 0.1325 h. Okay, y'all can write it as 0.133 lah, because 3SF, right? Okay. Question C. At the instance when x equals to 2, y is increasing at the rate of 4 units per second. Find the corresponding rate of increase in x. Okay, so this is the rate of change question. So we have to find 3 derivatives, and then we apply chain rule. That's how we actually solve for this question. So find the corresponding rate of increase in x, right? So they want us to find dx over dt. So what's given to us? Y is increasing at the rate of 4 units per second. That means this is dy over dt. They want us to find dx over dt. Okay, we need 3 derivatives, right? One more was from the previous question where dy over dx equals to 0.1325. Okay, you all can see over here. So the thing is, if you do the previous question wrongly, this one 100% also wrong already. So you got to be extra careful when you all do this question. Okay, so let's construct the chain rule. Dx over dt. Okay, if you want x to be on top, I can put dy over dt times dx over dy. So as you all can see here, we can actually rotate this. Okay, it's like a fraction like this. Dy over dt will give me 4 times dx over dy will be 1 over 0.1325. Okay, and you will get 30.2. 2 marks question. All right, so this comes under the topic of differentiation. First part, they ask you how to differentiate. Second part, rate of change. Third part, second part is approximate change. And then third part is rate of change. Okay, let's move on. Question 6. Okay, this is a very, very tough question, I would say. Okay, but it has come up before, so yeah, you all need to know. Okay, the normal to the curve. Let's read the question properly here. The normal to the curve of y equals to 1 plus tangent 3x at the point P with coordinate with x coordinate pi over 12 meets the x-axis at the point Q. Okay, meets the x-axis at the point Q. Okay, I'll put different highlight so that you all can see what exactly the statement is trying to tell you. Okay, then after that, they say here, the line x equals to pi over 12 meets the x-axis at the point R. Then finally, find the area of the triangle PQR. Okay, so what do we actually need to find here, right? We basically need to find the points PQR with the statements that is given to us. And then normally when we have 3 points on the graph, we can use the shoestring method, or another way, actually this there's an easier way to do it, which is actually just to use half times base times height. Okay, I'll teach you all that shorter method, because shoestring method, I think it will be a bit longer for this question. Okay, so there are certain questions that we can just use the formula of half times base times height. In this case, we can use it. So let's find coordinates of point P, Q, and R. Okay, so let's see from the statement here, what can we find first? Okay, number 1. Okay, this is number 1. They say the normal to the curve, this equation, at the point P with x coordinates pi over 12. So we know that point P, right? Okay, the first thing that we know, point P has x coordinate pi over 12. Okay, pi over 12. Therefore, what we want to do, sub x equals to pi over 12 into y equals to 1 plus tangent 3x. Okay, which will give you y equals to 1 plus tangent 3 pi over 12. Type in the calculator, 1 plus 1, 2. Therefore, P is equals to pi over 12, 2. Okay, so this will be my first equation. So this is according to the blue statement that I highlighted on top. Okay, second one. Second one that we can find is this green statement here. The normal, okay, of this curve meets the x-axis at the point Q. Okay, so what we want to do is we want to find the equation of the normal first. All right, find the equation of the normal. Before we find the equation of the normal, we need to find the equation. We need to find the gradient of the normal first. Okay, so find equation of normal. Equation of normal. Okay, let's see, how do we do this? So let's find the gradient first. This will be finding the gradient of the tangent first. So we differentiate y equals to 1 plus tangent 3x, which will give us 3 secant squared 3x. And here, sub x equals to pi over 12 into dy over dx, which will give us dy over dx is 3 secant square 3 pi over 12. Okay, we change it to 1 over cos square, and here will be pi over 4. Okay, type in the calculator, the value that you'll get is 3 divided by 1 over 2, which is equals to 6. Okay, so this is the gradient of the tangent. If we want to find the gradient of the normal, it will just be negative 1 over 6. You all can use the formula m1 times m2 equals to negative 1. Okay, so now I got the gradient of the normal already. Let's see, how do we find the equation of normal? Equation of normal by using what points? We use the point P, pi over 12, 2, and m, which is negative 1 over 6. Okay, so we fit into y minus y1 equals to mx minus x1 lah. So y minus 2 equals to negative 1 over 6 x minus pi over 12. Okay, expand the bracket, and you will get negative 1 over 6x plus pi over 72 plus 2. Okay, so this is the equation of the normal. Okay, the equation of the normal. So what do we say? Meets the x-axis at the point Q, right? So this equation of the normal, how do we find? We Want to find point Q? Since it meets the x-axis, that means my y is equals to 0. Okay, meets x-axis. Therefore, y is equals to 0. Okay, so we sub into this the equation above. So 0 equals to negative 1 over 6x plus pi over 72 plus 2. Okay, let's slowly find x as a subject. Plus 2, then multiply the whole thing by 6. So it will be pi over 12 plus 12. Okay, and therefore we will get q, which is equals to pi over 12 plus 12, 0. Okay, so this is your green statement. Okay, above. So you all should get this. Okay, then the last statement, the easy one actually, the line x equals to pi over 12 meets the x-axis at the point R. Okay, meets the x-axis at the point R. So immediately, actually, we have the value of this already. So if the line x equals pi over 12 meets the x-axis at the point R, means the x-axis means my y is equals to 0. And then my x value, my x coordinate will just be pi over 12. So for point R, okay, point R, all I need to do meets x-axis. That means y equals to 0. Therefore, R will be pi over 12, 0. Right? Pi over 12, 0. Okay, so you all see here, right? I got all 3 points already. P, which is pi over 12 here. Q, pi over 12 plus 12, 0. Then pi R was pi over 12, 0. Okay, now let us plot this into, okay, let us plot this into a graph, okay, an x and y axis. Then you all will see that actually I can just use half times base times height. Okay, you only do this if you understand, if you see that it's a, like you can draw a nice triangle. Otherwise, you all can just use a shoestring method. So if I were to plot, so P is pi over 12, 2, R is pi over 12, what is it? Pi over 12, 0, right? So they're actually a straight line like this. Okay, so if I were to just roughly plot, P is pi over 12, 2, Q is, sorry, this is not Q, this is R. R is pi over 12, 0, and Q is pi over 12 plus 2, 0. Okay, how do I know to use this method? In fact, this type of question has been repeated a couple of times already. Okay, and I think, yeah, most people use shoestring method, but I find this way actually way easier. Okay, so now you see, I can draw a very nice right angle triangle here. My base, in this case, pi over 12 plus 2 minus pi over 12, this will just be 2. And my height is also 2. Wait. My Q is not pi over 12 plus 2. It's pi over 12 plus 12. Okay, that here. So we will use, my base will be 12. So can I just use half times base times height? Yes, I can. So area will be equals to half times 12 times 2, which will give me 12 units squared. Okay, or you just write 12 also, you'll get correct already. And this is how you get your 8 marks. Okay, so you can either use shoestring method also. Okay, shoestring method, which I won't go through because I like this method better. So I've trained my students to actually do this method, which is a much simpler way, in my opinion. You just need to sketch it out, then you can see it clearly. All right, cool. Let's go. Next one. Question 7. Okay, question 7. A curve y equals to fx such that d square y equals to 2 minus 3x power negative 1 over 3. The curve passes through the point negative 2, 10.2. The gradient of the tangent to the curve at negative 2, 10.2 is 6. Find fx. Okay, so for this kind of question, we actually just need to integrate it because they are basically giving us d square y over dx square. I integrate, go up, I'll get dy over dx. I integrate some more, I'll get back to y. Okay, y is equals to fx, right? So every time, this is a indefinite integral kind of question. So every time when we integrate, make sure you put in this thing called the plus c or plus d. That value that you have to find is called the arbitrary constant. Okay, the arbitrary constant. Okay, so let's see. D square y over dx square will be equals to 2 minus 3x to the power of negative 1 over 3. Okay, so we want to find what's dy over dx first. So let's integrate this. Dy over dx, which I will get is integrate 2 minus 3x to the power of negative 1 over 3 dx. Okay, 2 minus 3x power plus 1, so it will become 2 over 3 over 2 over 3 minus 3 plus c. Okay, simplify it, we will get negative 2 minus 3x to the power of 2 over 3 over 2. Okay, here and here will cancel off. Then we'll get plus c. Okay, so what was given to us in the question? Gradient, so they say dy over dx is equals to negative 6 at the point negative 2, 10.2. Okay, negative 6 at negative 2, 10.2. So what do I need to do? Dy over dx. Okay, we sub in dy over dx equals to negative 6. For this one, we will need to sub in the dy over dx and the x. Okay, we sub into the previous equation that we found. So negative 6 is equals to negative 2 minus 3. Let's see. Negative 2 over 3 over 2 plus c. And then we'll get negative 6, negative 8, 2 over 3 plus. Okay, just type all of this in the calculator. Don't waste your time doing manually. Negative 2 plus c, and we'll get c equals to negative 4. Okay, so make sure you find this plus c. If you don't find plus c, you confirm your equation will be wrong already. Okay, this is for your indefinite integral. So my dy over dx will be equals to negative 2 minus 3x 2 over 3 over 2 minus 4. Okay, so this will be my dy over dx. Okay, after I find my dy over dx, I want to find y, right? Okay, find y. So we repeat the same process again. We integrate this equation. So y is integrate negative. Okay, I'll just put the 1 over 2 out so it's easier for me to see. 2 minus 3x to the power of 2 over 3 minus 4 dx. Okay, repeat the same process. So integrate it, we'll get negative 1 over 2, 2 minus 3x to the power of, now will be 5 over 3 over minus 3, 5 over 3 minus 4 x. Okay, I will write plus d right now. Okay, you can write plus c, you want to write any alphabet, but normally if I first one I put c, the second one I'll put d. This is a constant, so we want to find what is the d. Okay, let us simplify a little bit more first. So 2 minus 3x 5 over 3 over 10 minus 4x plus d. Okay, so now I want to find d. So I sub x equals to -2 and y equals to 10.2. Okay, I don't need the dy over dx anymore. Okay, find d, which will give me 10.2 equals to 2 minus 3 -2, 5 over 3 over 10 minus 4 times -2 plus d. Okay, which will give me 10.2 equals to 8 to the power of 5 over 3 over 10 plus 8 plus d. Okay, just type all of this in the calculator. Here you get 11.2 plus d, which will give you d equals to -1. Okay, which my final equation will give me y equals to 1 over 10, 2 minus 3x to the power of 5 over 3 minus 4x minus 1. This is my final answer. Okay, I actually just sub it back to here. This is to find the d value. Okay, how are y'all feeling? Good? Okay, I know all my students, because the ADDMATHS exam is in 2 days' time, so all of them are like messaging me, teacher, we are so stressed right now. Yeah. Okay, y'all can do it. Y'all can do it. Okay, just need to know how to do it. In fact, all these questions, if y'all have practiced enough already, yeah, y'all will have seen this pattern before. But if y'all haven't been practicing, then y'all should panic a little bit. Okay, or prepare better next time if y'all decide to do IB or A levels or any other courses. Okay, let's go. Next one, question 8. Okay, in this question, all lengths are in meters and all times are in seconds. A particle A is moving in the direction -20, 21 with a speed of 58. So this is the direction. When we say about speed, this is actually the magnitude. Okay, so how do we do this kind of question? It's just a 1-mark question. I won't go so much into the theory of it, but we'll just learn how to solve it. So let's find the magnitude first. So magnitude will be square root x squared plus y squared, which is equals to square root -20 squared plus 21 squared. You'll get square root 400 plus 441 equals to 29. Okay, so we want to find how many times bigger is it. This is like the constant lah, which is you just take the value that's given to you, then you divide by the magnitude that you found. Okay, so this is 2 times. Therefore, your velocity vector of this, okay, your velocity vector is equal to 2 times the direction that is given to you, which is -40 and 42. Okay, so this is actually just a 1-mark question. Question B, given that A is initially at the point with position vector 5, -3, write down the position vector of A at time t. Okay, for this one, what we need to use is, okay, y'all might use different alphabet, it doesn't matter, but for me, I just remember as A equals to U plus VT. Okay, A will be final position, U is your initial position, then V is just your velocity vector. Okay, so we want to find an equation that represents the A. Okay, OA. This is actually OA. How A is traveling. So initial position is 5, -3. That's given to us. Then plus -40, 22 t, which would give me 5 minus 40 t minus 3 plus 22 t. Okay, this is also 1 question only. Okay, last one. A particle B starts to move such that its position vector, at time t is negative 35t plus 4, 44t minus 2. Find the displacement vector AB at time t. So displacement vector means the relative position between A and B right now. Okay, so this is OB, the position vector that is given to us is OB. So the equation that you want to be writing is AB is equals to OB minus OA. Okay, OB minus OA. Okay, so let's just sub it in. Negative 35t plus 4, then 44t minus 2, minus 5 minus 40t, minus 3 plus 42t. Okay, go and minus all of it off. Okay, minus all of it off. We get negative 35t plus 4 minus 5 plus 40t. Then 44t minus 2 plus 3 minus 42t. And you will get minus 1 plus 5t, 1 plus 2t. All right, let's go. Question D. Okay, question D. Okay, then they say hence. Hence means normally we need to find the previous, use from the previous question. Find the distance AB at time t in the form square root pt square plus qt plus r. Okay, so if you can see here, the word distance, right, is actually a magnitude. Okay, displacement and distance. So we need to define what is the definition of a scalar and vector. So this we learned that displacement is a scalar, is a vector quantity. Distance is a scalar quantity which has only magnitude. So when we want to find distance, we just find the magnitude of AB. Okay, so you will get square root negative 1 plus 5t squared plus 1 plus 2t squared. Okay, then let's solve this. 1 minus 10t plus 25t squared plus 1 plus 4t plus 4t squared. Okay, you should eventually get 29t squared minus 6t plus 2. Okay, that's how you get your P, Q, and R. Okay, let's go. Question E. Find the value of t when the distance AB is 6, giving your answer correct to 2 dp. Okay, so they say right now from the previous question, we already find what's our distance, right? And they say it's equals to 6. So we just need to solve the equation for this and find your t value. Okay, one thing to take note of is your time cannot be negative. So if you ever get a time that is negative, we gotta reject it. Because we cannot turn back time, right? We're not back to the future. Okay, cannot time travel. So 29t squared minus 6t plus 2 will be equals to 6. Then 29t squared minus 6t minus 4 equals to 0. Okay, how do I do this? Okay, every time when you do quadratic equation, right, my advice is that you just go use your calculator to check first. Okay, if you don't know how to use your calculator, go Google it. If you see it's irrational number, your value is irrational, then just go and use a quadratic formula. To be safe, just show the working. Okay, don't just type in the calculator because the marker will know that you just use the calculator. Okay, so we put this into quadratic formula. -4 over 2 times 29. Okay, which will give you 6 plus minus 36 plus 464 over 58. Okay, just type all of this into calculator. 6 plus minus 500 over 58, which would give you 0.49 and negative 0.28. We got to reject this because time cannot be negative. So your final answer will be 0.49, correct to 2 decimal place. Okay, let's go. Next one. Question 9. Okay, I think question 9 is not too bad, but you can get a little bit challenging. You see, there's another graph type of question. Okay, so function f is such that fx is equals to ln 5x plus 2 for x more than a, where a is small as possible. Okay, write down the value of a. So a is actually just your domain. So your original domain, how do you find, is just for ln graph will just be 5x plus 2 more than 0, which will give you x is more than negative 2 over 5. Okay, so we can roughly actually just sketch the graph out here. Okay, so my asymptote will be negative 2 over 5. Once again, you don't have time to go through the theory of this. You need to understand how does the ln graph looks like. Okay, hence find the range of f. Okay, the range of f is actually all real values. Okay, from negative infinity to positive infinity. So how can we write it? We can write it as it is all real values, like this. Okay, then the question 3 asks us to find the inverse of it, stating its domain. So this is the way that I teach my students. We always let f inverse x, let y equals to f inverse x, then fy will be equals to x. Okay, you all can just follow whatever method that your teacher teach you, but this is a consistent method that will always be right. Okay, inverse the ln, we will get e to the power of x. Then you get 5y equals to e to the power of x minus 2. And then y will be e to the power of x minus 2 over 5. Therefore, your f inverse x is equals to e to the power of x minus 2 over 5. And then they say stating its domain, right? So the domain of the inverse will be the range of your original fx. So my range just now is what? All real values, right? So now here also, my x is all real values. Okay, and this is how you get your 3 marks. Okay, next one. On the axis, sketch the graph y equals to fx and y equals to f inverse x, stating the exact values of the intercepts of the curve with the coordinate axis. Okay, so we need to know how the graph of ln looks like first. Because without having an idea, yeah, we'll never know how to sketch this. So given to us, the graph is what? Fx is equals to ln bracket 5x plus 2, right? We need to know also the inverse of ln is an exponential graph and vice versa. Okay, so actually what we are be sketching here is just a long graph and an exponential graph. Okay, so the fx will be a long graph. The f inverse x is in fact just a exponential graph. Okay, so from the first one, what we know, right? The asymptote is -2/5. Okay, do we need to show this? I don't think so, but the main thing is, okay, they say stating the exact values of the intercepts of the curve with the coordinate axis. So we need to show where is the x-intercept and the y-intercept. So my equation was y equals to ln 5x plus 2. Okay, so x-intercept means my y is equals to 0. So let's just sub in 0 into here. So 0 equals to ln 5x plus 2. And it will give me e to the power of 0, 5x plus 2. And we'll get x equals to -1/5. Okay, I'm going to skip a lot of steps because it's getting long, this video. Okay, so we will get our x-intercept is -1/5, 0. Okay, then we get the y-intercept, which is when my x is equals to 0. So y equals to ln 5 times 0 plus 2. And you will get y equals to ln 5. Okay, so my y-intercept will be 0 and ln 5. Okay, 0 and ln 5. So how do I know? So a ln graph looks like this. Okay, roughly sketch, huh? And then my x-intercept will be -1/5. Okay, make sure you show it clearly. Then my y-intercept will be ln 2. Okay, let's sketch the exponential graph right now. So exponential graph is just the inverse of a ln graph. Therefore, if it's an inverse, right, that means all my x will become y and all my y will become x. So same goes for the intercept also. Okay, the intercept here, this one will be -1/5. Then here will be ln 2. Okay, so what I'll be drawing will be this. Okay, so this is my fx graph, and this will be my y equals to f inverse x graph. Okay, fx and f inverse x. This is how you do it. Okay, next one. The function g is such that gx equals to x to the power 1/2 minus 4. Solve the equation g square x equals to -2. Okay, so g square x is ggx. Don't go and square the entire equation. It's a composite function. So gx is equals to x to the power 1/2 minus 4. Okay, let's find what is g square x first. Okay, they say g square x is -2, right? So ggx is equals to -2. Okay, how do I find ggx? Okay, maybe I should do one at a time. Okay, let's find what's g square x first. So ggx is equals to gx to the power of 1/2 minus 4. If I do composite function, it will be x to the power of 1/2 minus 4, 1/2, then minus 4. Okay, now we use this equation, the g square x equals to -2. X to the power of 1/2 minus 4 to the power of 1/2 minus 4 is equals to -2. Okay, I'm using this equation right now. Okay, let's solve this. Bring over the -4 first, which will give me +2. Square the whole equation, which will give me 2 square. Okay, will give me 4. -4 will become +4, therefore 8. And 1/2 again, we square the entire equation, therefore it will become 64. Okay, so x will be equals to 64. Okay, last one. I hope that all of you are still doing okay. Okay, let's go. Last one. Okay, 10a. The first 3 terms of an arithmetic progression are sine 3x, 5 sine 3x, 9 sine 3x. Find the exact values of x where 0 the domain of x is 0 to pi over 2, for which the sum to 20 terms is equal to 90. Okay, so this is an arithmetic progression. They give us the domain is from 0 to pi over 2, and then they ask us to say, they say the sum to 20 terms is equals to 390. Okay, so let's use all of this information. What we want to write the information that's given to us first. So first term, sine 3x. Second term, 5 sine 3x. Third term, 9 sine 3x. Okay, we find what's our common difference first. So your second term minus the first term. So 5 sine 3x minus sine 3x, which will give you 4 sine 3x. Okay. What else is given to us? The first term that we know is sine 3x. And then they also give us what? S20. Okay, the sum to the 20 terms is 390. Okay, so y'all can go to your formula sheet and actually refer to the formula there, where this is the formula that y'all want to use. N over 2, 2a plus n minus 1d. Okay, we know that S20 is equals to 390, right? So 390 equals to 20 over 2. 2a is sine 3x plus 20 minus 1, 4 sine 3x. Okay, we are trying to solve for x, the exact values of x. Okay, so let's solve this. 10, 2 sine 3x plus 19, 4 sine 3x. Okay, we divide the whole thing by 10. Okay, 2 sine 3x plus 19 times 4 sine 3x, we'll get 78 sine 3x. Okay, we want to solve for this trigo. So sine 3x, we put it as the subject. Then you'll get sine 3x equals to 1 over 2. Okay, so this is how it became a trigo question. You see, from a progression, arithmetic progression kind of question, became a trigo type of question. So, all right, this is the method that I teach my students. You find what's your base angle first. So just type in your calculator, shift sine 1 over 2. In this case, you will get pi over 6. Okay, it's in radian mode, so it's either you get 30 degrees, but because of the domain that's given to us is in terms of pi, therefore we write it as pi over 2. Okay, one thing you all have to observe, you see, they say that the domain that is given to us is 0 to pi over 2. Okay, 0 to pi over 2. Now, they want us to solve the trigo, right, is 3x. So I need to multiply this by 3 until 3 over 2 pi. Okay, 3 over 2 pi is until which quadrant? 3 over 2 times 180 is until third quadrant. Okay, if you all see, type in your calculator, it's until 270 degrees. So it's from Q1 to Q3. So we only need to take the values from Q1 to Q3. Okay, so we draw our ASTC graph. Draw ASTC graph. And then S is positive, right? So A and S. So first quadrant and second quadrant. All right, and our base angle is pi over 6. Therefore, 3x is equals to pi over 6 and pi minus pi over 6, which will give me 5 over 6 pi. Okay, my answer for first two quadrants. And you will get pi over 18 and 5 over 18 pi. These two will be your answer. Okay, this will be a 6 marks question. Okay, one last one. Question B. The first 3 terms of a geometric progression, okay, is 20 cos y, 10 cos square y, and 5 cos power 3y. Explain why this progression has a sum to infinity. Okay, so you all go back to the first formula sheet, right? You all will see this, the criteria for geometric progression. And for the sum to infinity to exist, right? There's actually this criteria that most students always leave out. So S infinity, we know is A over 1 minus R. But there's this criteria at the side here. You see the modulus R is less than 1. Okay, so that means, right, your R value needs to be in between -1 to 1. That is the criteria. Okay, so let's find what is our R first. So which is our common ratio. You take the second term or the next term, divide by the previous term first. So the way to do this is you find the R values first, which will give you 1 over 2 cos y. Okay, so let's look at this, whether the R value will be satisfied or not. So we know that the original cos value, the domain is from -1 to 1. Okay, remember your graph. Okay, this is from -1 to 1. Okay, so now the R value, right, we want the cos R to appear. So we multiply the whole thing by 1 over 2. Okay, all three values. So you get 1 over 2 cos y. And here will be -1 over 2. Here will be also 1 over 2. And 1 over 2 cos y was the R value, right? So R is in between -1 over 2 to 1 over 2. And this satisfies the equation of this. Okay, it is within 1 and -1. Okay, within 1 and -1. Okay, therefore, sum to infinity exists. All right, so this is the explanation behind it. Okay, very last one. Then we are done. Okay, I am hungry. Time for dinner. Okay, so find the value of y, where y is in radians in 0 and 0 is y is in between 0 and 2, for which the sum to infinity is 9. Okay, correct your answer to 2 decimal place. So let's write down the information first. S infinity is equals to 9. Okay, then with the information that's above, we need the A over 1 minus R, right? So R just now, okay, A, we see the first term, which is 20 cos y. R is equals to 1 over 2 cos y. Okay, 1 over 2 cos y. Okay, so we sub into the equation. We know that sum to infinity is A over 1 minus R. Okay, A over 1 minus R, which will give me 9 minus times 1 over 2 cos y. Okay, we cross multiply it. 20 cos y. Okay, let's go and solve this equation. Okay, 9 minus 9 over 2 cos y equals to 20 cos y. Okay, and we will get, okay, just go and rearrange it. For 9 over 2 cos y equals to 9. Cos y will be equals to 18 over 49. Okay, 18 over 49. So we solve like our normal trigo. So we find our base angle first. 18 over 49. This will be 1.19 radian. Okay, so just now they say, right, the domain of y is 0 to 2. Okay, 2, the value of 2, right, this is 2 radian. If you change it to decimal place, right, it will be until 114.6 degrees. That means, right, your range, your domain of values, right, that we can consider is from 0 to 114 degrees, 114.6 degrees only. That means, okay, we will take first quadrant and maybe a bit of second quadrant. So let's just consider it's the entire second quadrant. Okay, why it's always important to see the domain, right? because we want to see which quadrant to look at. It's not always just ASTC and 360 degrees. Okay, that's the common mistake that most students always do. Sometimes you might get it right, sometimes you might not. Okay, so we actually have to use the proper method, and I realized that most teachers don't know how to do this method of actually considering the domain. Okay, it's not always just ASTC. So in this case, we know that it is just first and second quadrant. Cos is positive, okay, supposed to be first and fourth quadrant, right? But do I need to consider fourth quadrant? I don't. Okay, because you all can go and do also. You all go do fourth quadrant, you'll see eventually your final answer, you have to reject it anyway. So why waste time doing it if you understand this domain part? So since second quadrant is not part of it, so I only need to calculate my first quadrant. So alpha or my y value will just be 1.19 radian. Is that it? Yes, it is. All right, so I hope that you all have learned how to do this paper. Honestly, this is not an easy paper. Yeah, you see, even me just explaining it takes about 1.5 hours already. So for those who are sitting the IGCSE ADDMATHS exam, whenever you're watching this, yeah, if you like to support me, go and find my Instagram, go like my Instagram, subscribe to this channel, and I hope this paper has helped you. All the best, and I'll see y'all soon. See y'all. Bye.